Board.
Did you order the Wi-Fi 8 or just a regular ESP8266?
There's like a 2-pack for $12.
USB built into it, or do you have the pins?
USB.
All right. Kick her off. Let's
get started.
Oh, cool.
Welcome to June. OLUG, Omaha Shoes Group. I'm John Larson. I am a director of the AIM Brain Exchange here.
Ooh, director?
Yeah.
Wow.
That's snazzy.
That's easy to give you money, I suppose.
Yeah. Well, if you got any, we'll take some. Fundraising, get your name on the wall.
Where on the wall?
Sponsors.
Oh.
Does that mean?
I got a Sharpie. I don't need any.
It's not.
We have our full swing summer camps starting up this week and next week. We'll have roughly 60 to 80 kids here at one time.
Wow!
Every day. It'll be a challenge, that's for sure. So this month, Aaron has decided to talk about the ESP8266 and the Internet of Things. So I'm sure that we'll hear about some things as he's trying to edit a file. But is it working okay?
VI not found.
VI not found?
Yeah, there's a story about that as well.
Well,
it's
Emacs, Nano, Pico.
No.
Vim it is.
All right.
So, Heart of the Developers Conference, when's that starting?
September.
They just closed the call. They just closed the call for papers for that, right?
Yes, they did.
Nice.
Is that a microphone?
That's
a battery pack.
Oh yes, no battery pack. It's a very grody battery pack.
I don't know. It looked like a microphone, but I guess it's a flashlight.
It's a flashlight and so much more.
Amazing.
Yes. It's amazing you can find me searching for a battery pack at 3 in the morning. I find a USB battery stick.
Oh, cool. How's that going?
I think we have a editor.
Woo.
Yes. Woo.
Great.
Q4OS is a very interesting OS.
I can see that.
No, it's actually quite fascinating when it works. You got any announcements? Who's speaking next month? Out of curiosity.
Probably me.
In July?
I'm the one.
Third.
Are
we having a meeting in July?
Let's start with that
question. All in favor of a meeting in July, raise their hand. You almost raised your hand.
I can't do that because that's my anniversary.
Oh, well, you're excused.
Thank you.
This time.
Well, I guess not. I didn't pay that much attention to the calendar.
I realized it was the 3rd. Wow.
Neither did I. Huh. I thought it was like the 5th. Oh, well. We'll get back to that.
No, it is because the 11th is when the Nebraska Cert class starts. The security freshman training class starts again. That's Wednesdays. Yeah, it is.
All right.
Cool.
Well, I'll revisit that calendar then.
Yeah. Excellent.
I don't know why I didn't cross it off from the OLUG schedule and I put it out there.
That's probably the one Brian put himself down for.
Yeah, it's the 3rd.
No, I put my name in there.
Oh.
So he wouldn't be able to.
Cool.
Now that that's on video. Would you like to talk about the Internet of Exploitable Things?
We'll talk about that in a minute, but first, Q4OS.
Yes,
Q4OS is a very interesting OS in its own right because they do two things. They keep the Trinity desktop, the old version KDE, alive, and they also install under Wubby, which if you remember Wubby, what it does is it creates a file on your local Windows 10 system that it then mounts in loopback and actually runs against.
Oh, yeah.
What's interesting about this is it works under Windows 10 with Secure Boot because it has a signed executable. So if you actually go into your BIOS and your whole control thing, you'll actually see options of recovery, Windows 10, Q4OS, Scorpion in this case. So it's actually, you can actually install it underneath Windows without actually repartitioning a disk or anything yet under Windows 10 because it actually understands the key manager. For a while there, you had to use the key manager to actually accept the certificate into it and stuff like that. But without that, you can actually, any machine, Windows 10 machine you have permissions on, you can actually install it on. And on this wonderful piece of crap, you really do need every last little bit of oomph you can get.
Didn't Ubuntu have something like that?
They did, but it stopped after Windows 7. Because Windows 7, Windows 8, they kind of killed it off with the bootloader and stuff like that. I mean, it goes back. There was Topo Gijo Linux or something like that. There's versions of Fat Slack and stuff. But working under Windows 10 under Secure Boot without having to turn it off in the BIOS, which is where it gets interesting. So, but it's actually not bad OS. But the Trinity desktop is freaking ancient. I mean, it's astonishing. They're actually starting to move to KDE 4 because I mean, it's time.
Are you? Is that an Intel graphics laptop?
Yep. It is the cheapest laptop I could buy at Best Buy at the time, $200 and worth about half of that. It's a Celeron processor, 4 gigs of RAM, 500 gig hard drive, and Windows anti-malware will eat 80% of the CPU on it for days, just analyzing it. Chunk. It never finishes. I think it starts the next game.
Or if you swapped it up completely out, it's not too bad.
I don't know. I haven't swapped it completely out yet. I want to just run some tests with this first. But the problem is you're running a loop back, so you're paying the overhead penalty because you're using the NTFS driver on top of it and stuff. So it's still not perfect.
But I mean, I'd swap out.
Yeah. Yeah. Well, the reason I bought it is I wanted something with a Windows license on. I didn't care about if it died. So that in itself is kind of interesting.
Yep, you're right.
Let's get over here. So, all right. So, how you can make an Internet of Thing for less than $15? And I cheated because I did it. I bought one thing that had everything I wanted in one piece, which is the way to go with it. Why? ESP8266 are available for as cheap as $1 a chip if you buy in quantities. Admittedly, very large quantities, because you got to AliExpress, there's options to buy 1,000 of them or 10,000 of them, that kind of stuff. For a single chip, you can find one for a couple of dollars. Not bad at all. There are a lot of different ways to program the chips. We'll talk a little bit about that. For very simple tasks, such as remote sensors, they work tremendously well. You can power them off a couple of lithium-ion batteries for a couple of years. There's people who are working at there's a whole group of Hackaday that's working at nothing but trying to get them working on coin cells for a year.
So when you say, okay, so lithium-ion battery is like a 18650
or 2 just AA lithium-ion batteries, an adapter on the bottom. So there people are playing with all sorts of stuff. Hackaday, they're just going insane with these.
You know, a lot of the home security, like those motion sensors, those run off of the lithium CR123.
Yeah.
batteries.
Yeah, I mean, those will work quite a bit too. There's still a work on that. The one thing about the 8266 is if you can wire one pin to another pin, it'll actually be able to wake itself up. So you can put it in a deep sleep mode and then have it actually wake up. So if you're doing something like a moisture sensor for seeing if there's water in your basement or something like that, that is tremendously cool concept.
Oh, yes. Well, good. There's an application already for me.
There's a ton of applications. It's a really cool little chip. I think I talked a little bit about how to compare Raspberry Pi later on, but the experiments going on at Hackaday and stuff like that, with how low you can go in terms of power and stuff, are just phenomenal. People are just trying to figure out all sorts of things. How does it compare to a Raspberry Pi? Everybody wants to know that. The ESP82 is a lot less powerful than Raspberry Pi. It runs at 60 or 120 megahertz. It has 32K of memory, a couple mega flash. It's next to nothing. So it's a very simple, very small chip. Yeah. The ESP8266 runs really small OSs. There's some guys who actually have got a version of Unix running on it. What they did was they went out and they grabbed the old Unix version 6, which if you're really old like myself, you know what that actually means. That's the version that ran on PDP-11s, which were the tiny computers that were, the small computer was roughly the size of a Honda minivan. So Very cool stuff. The ESP8266 uses a lot less electricity than a Raspberry Pi and may work in environments where the Pi is overkill, such as remote sensors. One of the examples being that people doing the Arduinos and stuff like that is they tend to use Raspberry Pis for the monitoring, displaying information, but for actually running the code and doing the actual turning stuff on and off, they tend to use the Arduinos and the Arduino-like chips because they do not crash as often. Raspberry Pis work pretty well, but every now and then you're just gonna, their uptimes aren't quite as high as in case Arduinos and stuff like that. So I'm still playing around with this. I've been playing with these for a while now. I've got a project I'm working towards the end, which I'll talk a little bit more about. Some very cool stuff though. If anybody has any questions or wants to correct me on anything, by all means. Yes?
How big are they?
They are the size of roughly the tip of this. Yeah, but this is more than just
There's a lot of support elements on there.
This has several.
But you need all these support elements.
No. There's a variety of different versions. This version has a screen on it, which you don't need in a lot of cases. It has a USB programmer on it, which we'll talk a bit about later on, which you don't need in most cases. All you really need is just the little tip, which is a chip and 8 pins, which we'll take a look at some variations of that here a little bit. History of the 8266, Arduino happens, everything goes insane. People start looking at chips a whole different way. People want to Wi-Fi enable them. Expressive releases an internet-enabled light bulb. They also released a chip as an add-on for Arduino. So originally this was a shield for Arduino. You plug it into Arduino into it, and you'd be able to Wi-Fi enable it. Some guy, once again, very smart guy, took a look at it and figured out, hey, there's an Arduino inside this thing. So why do I need an Arduino to talk to the Arduino? Why can't I just use the one that's built into it? And people figured that out. The great thing about this is people read all the data sheets and reverse engineered the documentation SDKs from, they initially used the docs, they initially used Google Translate to translate them from Chinese. And then they went through and cleaned them up a bit, and there's still a whole process. But people buy a lot of these, use a lot of them, because you don't tend to be as attached to a chip when it's $2 as opposed to when it's $35 or $100 or $200. Yeah, let's take a quick peek at some ESP8266 options.
My top 4.
Everybody's top 4. Oh, come on. Come on, baby. I'm driving backwards, so this is always interesting. Oops. If I can see this to duplicate, that would be so nice. Let's go to AliExpress. Amazon, yeah, we'll start with Amazon. ESP8266. So you can get 3 of them for 20 bucks. You can get an individual one for $8.39.
And those have
yep. If you ever see this on the ESP8266 chip, that is the antenna for Wi-Fi. Some of them have actually additional place where you can put an additional antenna on it, so a little screw, so you can just put a regular Wi-Fi antenna in case you want to actually go distance. But
are they 5 gig or
2.4? They're due NNG. I think there's 0.4 for mostly though.
2.4?
There's another chip we'll talk about later on called the ESP32, which is phenomenal. Which is the successor to this, which is very cool. But if you want just the ESP8266, let's say you want 4 of them, $12.99. That is a base ESP8266. That is roughly about the size of a little bit bigger than a penny, but a little smaller than a nickel. The deal here is you have 8 pins, power, ground, transmit, receive, and 4 general purpose I/O pins. You have next something else with it. To be able to program this easily, you either have to come up with a serial USB device, some form, or you can scroll down the page further on and just get a USB to serial adapter for about $5, $6 and plug them into that. Which if you're going to do in scale, obviously there's a whole lot to be said for it. The way I'm looking at them, I don't really mind spending an extra $1 or $2 for the USB program. But if you look at these two, you'll see the comparison here. If you were to flip this one around and compare it to this is an 8266. These are pins so you can drive stuff with it, breadboard and all that kind of stuff. And that's a USB program at the top. But, oh.
Is that the one with the screen right there?
Yep, that's the one I have. Make a focus. Actually, the one I have is from a company called High-Tech. High-Tech, actually, no, it's Heltech. I keep forgetting that. It's helltech.cm. We'll take a look at their website in a minute. It is pretty hilarious. But there's a million different options. You got to AliExpress, there's thousands of different variations of this. You can get bigger screens, smaller screens. If you go to the, we'll talk about later on, but if you go to the ESP32 route, you can get them with e-paper screens.
Cool.
For like $30 a piece. And you start thinking about that, what does that do to your point? That drops your battery usage. You only use the battery when it changes stuff. So there's actually, they have experiments where they've actually went through and did a whole freaking store and replaced all the price tags with those little chips with little
That's
OLUG.
Probably what NFS uses.
Yeah, I wouldn't be surprised at some variation of it. But it has a 2 to 6 to 8 second ratio to flip them and stuff, but it's phenomenal. But yeah, no, it's just amazing how much you can get on those. I got to hit AliExpress because I haven't hit it in a couple hours. You know how I get if I don't.
A little withdrawal.
A little bit. But there are a million different options for it. Yeah, temperature and humidity sensor, 276. Very cool.
Right into it.
Yep. That one's actually, the Wemos are actually really popular. They do a lot of things for you, make it a little easier in some respects. But yeah.
That's just the basic one right there.
Yep. $1.74 a piece. So it really is hard to knock that part of it. All right, so things to consider. Serial USB adapter is kind of nice. If not, you can get one for like $6. They have them that have just the 6 pin, that have the 8 pins, and just a USB adapter port on, so you just plug it right in your computer and program it. Very nice. Node MCU makes it a little easier to program. Number of pins, depending on how many input output you want. You can do some stuff with multiplexing. RAM 512K or 1024K. You know, you always want to get the best. You have to read data sheets to get all the info, and that in itself can be a pain in the butt because a lot of times you're not going to see it in what you want to. It's going to be in Chinese still because a lot of this stuff hasn't been translated. And so available SDKs, OSs, Arduino C++ firmware, Node MCU, Lua supporting firmware. If you ever use Lua, it's a really popular, very small scripting language. It's one of the smallest ones. It's embedded in a lot of things like people are using it to program Warcraft and stuff like that. It's a very simple declarative language. It's really pretty cool. It's one of the smallest ones around. MicroPython, Python supporting firmware. The Espruino, Node.js-like, so you can bring all the wonders of Node.js everywhere because it's going to be everywhere regardless of what you want to do. Node MCU and MicroPython run their languages as the OS. There's tons of others. There's the basic program language. There's some guy who's done Forth. There's all sorts of stuff. I don't know if there's anybody who's done a version of Lisp for it yet, but almost everything else exists. There's a couple different OSs for it. There's Mongoose OS. There's FreeRTOS. If you run the MicroPython or Lua stuff on there, the only thing that happens with the machine is it's in a it's called REPL, read, evaluate, print, and loop. It just runs that command over and over and over again for you. So it's pretty cool. MicroPython, this is what I've been playing with because I like Python. It's a subset, and I do mean subset of Python 3. There's a lot of stuff's not in there. Yeah, some stuff is a subset of regular Python. UJSON versus JSON, URequest versus request. Missing some things like the string class doesn't have L justification and so on. There are places where MicroPython obviously wouldn't be the best choice if you're in the point where you're trying to get every last CPU cycle out of it. It's not going to work that well. If you have a really large performance-intensive program, it's not going to work well. But for things like sensors, stuff like that, it works really pretty well. Yeah, if you have a task that requires every bit of memory, obviously you're going to be sacrificing some of that to the MicroPython runtime. my ESP8266. This is my ESP8266. There are many others like it, but this one is mine. There's a whole lot more to it, but I stopped for the profanity kicked in. Actually, this is the second one I bought, because the first one I bought of these, I managed to break the LED screen on, the OLED screen on. I did it very simply. I had a very short USB cable, and it kept flipping off the table. So I thought, hey, I will just pick it up very slightly, put my MacBook on top of it, and that will keep it from flipping over. I heard it. I heard it go. It still works. It just I don't have a screen anymore. So I went out and spent another $12 for this one. I've got a handful of these. I just got an ESP32, which we'll talk about a little bit later. And I actually went full hardcore in the ESP32. It's a dual core. That's how you know it's quality. So,
So 20 now.
I think it was like 23 because I wanted it to ship sooner. Yeah, this is a really simple ESP8266. The one thing that's unique about it is a 0.91 inch OLED screen hooked right up to it. So pins already hooked up, so you can just program right away on it, which for what I wanted is perfect. The only thing I really would like is if it was a little more sturdy, obviously. Would be nice. It's from Heltech. Let's go take a look at their website, because I think you guys go check out their website. You'll see how old my life goes sometimes.
How many pixels on the screen?
I have, it's like 160 by.
Go to the website, we could probably figure that out.
Yeah, stay with that idea.
Maybe not.
I've
seen some of those small OLED screens. Maybe
it's like 160 by 32. It can put 3 lines of text on it. So, Heltech CN. Come on, baby. Come on. Here we go. Here we go. And no, I don't want to translate. Why would I do that? That would be insane. So, move this a little bit.
It says scroll. This is the old Apple mouse.
I didn't say translate. I said don't translate.
No, you click. I watched you click on it.
All right, so I will go with English. Let's go to English, shall we?
Which they probably used Google Translate as well.
Yes.
Special change section technique.
Oh, yeah. All right, so we go to Product Center, and we look for OLED, the e-ink, all sorts of wonderful stuff in here. What we are looking for is the Wi-Fi Kit 8. The Wi-Fi Kit 32 is, of course, ESP32 based. All right, here we go. The Chengdu Heltech Automation Technology Company. So working temperatures, minus 40 to 90 degrees. So,
Celsius.
yes. Well, minus 40 centigrade is minus 40 Fahrenheit. Fun fact, if you grow up in North Dakota, you'll hear about that. Hey, kids, when you're on the way to school today, don't forget, minus 40 is the same on both thermometers. I hated that weatherman. Minus 32 megabits. But, yeah. So, lead to all pins, lithium-ion battery, charging disconnector, row needle spacing, pin figure, product specification. Let's see the data sheet. The data sheet should be...
Let's order 100 of them.
So, hey! Not all of it's in English. So, did I say product? No, but so you scroll through it, is what you do here. Let's see. I don't think that doesn't have anything to do with us. That's referring to a different one. Wi-Fi kit, 80 to 160 megahertz. 0.9, 128 by 32 is your resolution on that. 51 millimeters by 18 millimeters by 8 millimeters is the size, I would guess. And the good news is, through the process of playing with ESP8266, you will improve your Chinese. You don't have much choice, to be honest. But it's cool in its own right. So yeah, if they go the Wi-Fi 32 kit 32 BGNEI. So 2.4. Yeah. But no, it just goes through the basics. Actually talks about how you can actually install the, make the device actually recognized by the Arduino IDE, install all the stuff on it, which is what you end up doing with it. There's also instructions for this course in English in various places. And so I always thought this was just interesting because I always like to go to the horse's mouth to get the information, stuff like that. But in this case, well, the horse doesn't speak English, which they outnumber us by quite a bit. So. But so we took a look at the data sheet. We saw a couple various things that look like they might be close to what we're looking for. So disclaimer, we're going to run some commands on this that are going to wipe, reflash, and reset up my thing. Done incorrectly, these can cause issues for you on your system. If you type it wrong enough with flash stuff like that, just.
Do you mean your laptop or the little?
Depends on how badly you type. But no, I mean.
Push the firmware onto the wrong device?
Yeah. So let's start with the steps. First off, of course, is plugging it in. And if you plug it in the right port, it helps a lot. That's one of those things. You got it halfway there.
So far.
Yes. I have a little battery light running on it right now. It's one of the wonders of it. So let's take a shot at erasing the memory. All right.
And you're doing that on the screen we can't see.
I'm going to do this part on. I'm going to cut the commands over and put them on this command. You can, because I want to make sure I don't. All right. Come on, copy. Oh, you are such a special place. All right, or you can type it all by hand because you got no choice because it won't cut and paste. Yet another wonderful feature of. Really? All right. So, okay.
That's pretty.
You got to remember to turn off the display mode before you do that. So the first command is ESP tool, which is one to use to program that. Port dev TTY U0 USB 0 erase flash. And it is my night. Or you can just do it as sudo, which in this case you have to. Some OSs require it, some don't. Depends on how the permissions are set up. On regular debbing, it doesn't require anything differently, but on this one it does. So what we've done right now is we've flashed it, we've uploaded a stub, we've erased the flash. So right now this has nothing at all on it. It is totally, totally empty. The next step for us is to put an OS on it. Just cut for me. Come on, baby. Come on, baby. You can do it. Or you can just type it again like I will. So installing this ESP tool program, you install that very simply just by using pip install. If you've done any Python, you'll be aware of it. 46000. Come on. This would work so much better if I had cut and paste.
Is it in your command history?
No, it won't. It won't give it to me at all. Okay. So this is the next command. ESP tool, port again, same thing. Baud rate. Always make sure to have a good quality, shorter USB cable because the longer ones can have problems with the baud rate. Write the flash. I don't care what the flash size is. You figure it out. It's your job. So I set the text and just send it. What will I want to send it? The firmware. I went out and grabbed the firmware off of the MicroPython site. You can also go out and compile it up yourself if you want to. They have a Vagrant instance for it, which is kind of cool. No. And now we do this command again with sudo again. We're uploading a stub. We're writing the firmware. And we have hard reset the system. Now, if we reset it one more time, we will have nothing on it, but we should have a fully functional MicroPython instance, which we should now be able to talk to through picocom, which I will screw up that command, I know. All right. Now we are talking to MicroPython on here. So now if we do 3 plus 4, we get 7. We do all sorts of wonderful things. We can get stuff in here. We'll do something cool here called web REPL setup. And
So spit out your IP address.
oh, it does so much more than that. Okay. Okay, we want to enable it. We want to give it a password. Let's put OLUG in there. And now it will do a reboot if we ask it to. Well, it's not doing, it's a very small machine. So now I know. Yes, that is the. I want to make one other change to it first, but that's going to kind of suck when I have to come back. I haven't yet. That's why I'm trying to figure out how I want to do that right now. I'm just kind of a bit of a pain in the butt right now.
So it's making its own IP address.
Yes, if you connect out right now, if you look at the Wi-Fi access points right now, there is one called MicroPython. Oh.
So it is the access point now.
Yes, MicroPython 7A04E8 is now our access point.
Please don't take it over and ruin the demo.
Oh, or go ahead.
It's fair.
Yeah.
Just reflash it.
It's very funny because what happened to me at home was I lost the UPS, my battery when my UPS went out, and I had just a momentary blip of power. And there's now my battery's gone bad in the UPS. The minute it sees any power fluctuation, just shuts everything down. And of course, I have my most important systems plugged into my UPS. So everything else comes back up except for my router and all my stuff. So the only Wi-Fi access point I saw in my house that morning was the Arduino. It was the ESP8266. And now we can either connect to it directly, or I can push a command to it. Let me figure out what I want to do here. Come on. So I've skipped ahead a couple steps here. So we've already connected to it. What I'd like to bootstrap is the networking on it. I'm just trying to figure out how to deal with that. Cut and paste is a little rough. Oh, that'll work. Quit. Thank you. Give me Kate. There we go. Let's see if we can get something going here. All right. So what I want to do here is I'm off on another screen making a couple minor quick changes here. And it's getting more and more interesting. But so what we've done so far is we have a system, it's Wi-Fi enabled, it's able to understand a lot of that stuff. So we're getting pretty close to where we want it to be. And what I want to do right now is set my SSID to, this is actually working out well since I don't want to show this. I didn't want to show this part of the password in plain text. I thought it's a big deal.
Oh, you mean the branch?
Yeah. It'll be visible for a minute at least. All right, come on. reload file. There you go. So be more pain in the butt. Could you? All right.
So those are the MicroPython commands for you to just push all that information.
Yeah. Where's my oh, there it is.
Oh, so we missed it.
No, I haven't pushed it yet.
Oh.
I wouldn't be able to see anyway. So I should be able to, if here's one thing, if you do the MicroPython paste mode is Control E. So now if I paste that, I should be able to Control D it. All right, so what I've done is I've created a variable, A, which has the network configuration information on it. Now, if I reboot it, it should come up with an IP address. And then we should be on the AIM network.
Did you reboot that?
I am rebooting right now. And it did not give me a pass.
Oh, no.
00867.
That's open the ass. But why didn't it get an IP? Look, to see if it shows up on the access point.
It looked like you didn't actually do the file right in Python that you.
That was the one. That was the 174. We gave that length.
It said 154.
154. That was actually right in the thing.
154.
Yeah. So A is, I said, a variable here, yeah. That value. That is how it's spelled, right? John, is that right? How this thing is
in infrastructure mode.
I guess what I'm wondering is why you don't have 3 carets after that line then.
I do after this line. Oh no, these are it doesn't take effect until I hit Control D because it's in edit mode. You can put multiple lines in there. If not, Python the interpreter will automatically indent things for you, which is a pain in the ass. Lack of a better term. All right, we will do it once again the hard way because that's someday I'm gonna have a demo go right. Today is not that day, obviously, but someday, boys and girls, it's gonna be tremendous. And you're all gonna be there. And you're all.
Get a 172.16.
All right, let's try it. We'll do it the old-fashioned. We'll do it the other way, which is we go over here. We do a Control E. We'll do a print. We'll do a Control B. All right, 172.16.0.132. Okay. Which is interesting. I don't know why this giving me why it was giving me grief the way it was.
It says there's an update available. Go ahead. Take this all down. There's currently 34 connected devices. Azure Wave technology.
And it's, what was that address again? Was
132.
Oh.
ESP7804. It is idle.
Let's see if this will work. Actually, I may need to disconnect and reconnect. I need to disconnect and reconnect till I'm on AIM Exchange guest. I need to be on the brain exchange. Let me take care of that first. Configuring, deactivated. Come on, connect. Setting network address. Yeah, that's all good. So now we come over here. We should be able to. One question you're going to have is why is this in HTTP, not HTTPS? That's because the WebSocket restrictions. So I now have a connection over Wi-Fi. If I wanted to, I can unplug it from this and just plug it into this and reset it, and it should hopefully work.
Mirroring.
Yep. Yep. So now we have a full capability. What this gets us is this right here, which is what you really need, because life without this sucks so much. It does, it just does. What is that, you may ask? That is the ability to send and upload and download files on it. Because what I had to do before bootstrapping is I had to create a character file, a character array, and actually point it towards it. It's a limitation of the MicroPython environment. But right now we are running just the basics. But let me see where I'm at in the slides, by the way. So we have web REPL turned on. So theoretically now at this point, you can do anything you want to with this thing because it'll tend to hang on to the IP number and stuff like that. So, but normally for the most part, you normally don't have it running the web REPL all the time. You don't want to have that. That's a huge security challenge, let's put it that way. Yeah, but the basics, it is pretty much a straightforward system. It's a Python system right now. We'll just do them both. So if you import JSON, it's going to be a pain in the butt tonight. Import requests. All right, no module named request. What they've done is they've created a whole bunch of submodules on this. And there's a whole lot of modules that they have in there that are not actually valid. And that will piss you off. There's no way to
been changed to protect it.
Well, they don't have all the functionality implemented yet. An example being, if you actually try and import like config parser, it will say, hey, config parser is imported until you try to do anything with config parser. If you ever use config parser in Python, you tend to use that when you're doing little things with config INI files kind of thing. But we have it working that far. We're looking all right, good so far. So now we're at this point. Let's do the fun. We have a sore neck by the time this is over. So import machine. SSD 1306. That is, in fact, the wonders of, come on. So we're initializing that piece. Now we just got to get the OLED in there. So here's one thing I found out. If you give us the wrong information on the size of the display, you'll get interesting results. Let's just leave it at that. So now if I do OLED fill 1, I do OLED show. All right, notice how right now it is black. It is black, ladies and gentlemen, everyone. It is black. And now it is white. Ooh. That took about 3 hours at home, buddy. So that was that deserves. I will take your sarcastic ooh and take it more seriously. Move over a little bit towards this way. There you go. Thank you. Yes.
They didn't get to see black.
Well, we can fix that. But actually, let's put a little bit of text on there too while we're at it. Why is it giving me grief now?
Space.
Oh, you have to give. Oh, that's right. You have to. You have to give it where the location is. You're going to write the data at, and I'm going to write in just 00 location, and OLED show. Woohoo! Hello world.
It's on.
Yes.
I can see it.
Yeah. Well, let's just
Keep moving it. So.
Little persistence of vision thing. And you know what would really be cool is if you took one of these and put a gyroscope on it, you can actually do some stuff with that. So that gives you just a rough idea how you can actually control it. But by being able to program it all remotely, you can do some very cool things with this. What I did with it, which we'll talk a little bit about. Yeah, remember, you don't have a real OS. You got Python. You better know a little bit of Python. If you want to be able to figure anything out about it, we're back to importing OS. So if you want to see what old files are in the system, You do listers.
Oh, man.
Oh, OLUG. Or you spell it right. I mean, that really helps a lot.
No,
So
you had this OS.list underscore jurors.
yeah, I was wrong. And I did it right and it worked. That's wonders of the thing. I put a couple typos in one of my slide decks to see who's paying attention. But all you see right here is you have boot pie, you have the web REPL config pie, and you have the main pie. The main pie is that little networking program I wrote that just does the reset thing, which I don't know why that's wrong. I'm still annoyed at it. I know why it's wrong. It's because I cut and pasted in it. One of the great things about LibreOffice is, is the wonders that whenever you have double quotes, double quotes, double quotes, it converts them into the backtick version of it, of the quotes that go like that, you know, that other style of double quotes. And that does not, Python does not like those and it ignores those, so it turns it into a regular command.
List main.py. List.
Oh, no. You don't have a real OS. You skipped ahead a slide. How to cat a file. Well, let's take a look at it. Which one do you want to see?
Oh, main.py, because you were just saying.
Yeah, I think that's it.
That the quotes were done right.
I could be wrong on that. I've been wrong before. Ain't that fine? I will tell you, I suck at typing backwards. My head turned around. So, and see, when you do something that's in Python that has an indentation, if you don't need Python, it's just the wonders of it. So, thank you, Python. So, no, it didn't do triple quotes. I wonder why it's wrong on that. It does look right. Import network, station. Huh. Must have something wrong. I don't know what it would be though. But here's you a quick idea about how some of it looks. But that's part of the wonders of it, the learning experience of it, to be honest. So everything is all based upon your conversation with the Python interpreter. So you have OS gives you the capabilities to do everything like opening files, creating files, deleting files, all sorts of stuff. Or you can be a puss like myself and go out and use the web REPL interface to upload and download files. I would recommend you join me in the wussy land because it's much, much better, much easier. You can do all sorts of stuff by importing the machine stuff. There's a whole bunch of stuff. All the documentation on the micropython.org website. Right now they support like a whole bunch of different boards. There's a board that is totally open source based around this information, which is very cool. It's offered by Adafruit, but it costs more. Let's just put it that way. And that wasn't worth it to me to be, I didn't get on the high horse until it gets to the dollar sign sometime. But that other board is very cool in its own right. I'm looking forward to buying one sometime. So some libraries like shell utils aren't available because, well, you don't have a shell. So how would you shell anything out of it? So where are we at? We got a system running MicroPython. We've enabled the web REPL. It would be time to show the project. And I feel optimistic. Let's try the project. I'm betting 50% chance this works. 50. I'm feeling optimistic. So one of the things, if you're around me long enough, you'll hear me whine about air quality because as I have sinuses and stuff like that. And there is the United States government, in their kindness of their hearts, offers information about that. So you can see information about ozone, particulates that are 2.5 microns and smaller, and microns that are 10 microns and smaller, and moderate, good. And there's an API available for this. You can sign up for a key. You can go out and you can grab all this information. It comes back to you in JSON format. So very cool in its own right. So let me pop over here for a second. So what I'm doing right now is I'm modifying my program a little bit to aim, brain, So one thing about a MicroPython running on top of the ESP8266, there was two files in there. One was called main.py and one's called boot.py. What happens when it first boots up, it runs boot.py. Then after that, it will run main.py. So if you want to put any code in it that automatically starts when the system starts, put it in there. Yes, main.py is the one I recommend. Boot is also available to you, so you can do stuff that's dependent upon each other.
Is boot very long?
No, it'll be next to nothing, I believe. 025. All right. Now I should be able to open this Kate. Actually, I shouldn't have to do that at all. I should be able to just do that this one. All right, so here's the program a little bit. Let's take a little bit of a look at it. Let's go full screen with it. And we'll do Control++, so hopefully some people can see some stuff. So this gives you an idea what a whole complete program job is. Network, time, view request. Oh, one thing. Do not use this as an alarm clock because it sucks at time. Sucks hard at figuring out times. It's not good at all at it. Let's just leave it at that. So UJSON, date, time, init values. We're setting that stuff there. I initially was planning to put this in the config.ini, but I didn't, so I probably will sometime. Actually, what I will do with this is I will not put it in config.ini. I'll just put it inside a JSON file and just import it that way because it has the UJSON interpreter which can understand everything. Pretty straightforward. Init network should look familiar to what we've done before. Init display, get the data, takes the API key, which we have at the top there, sends it out, parses it. Left justify, I had to write my own version of that because it did not have one inside the string class. It's one of those things. Here's the display. Let's get a little bit of information for you, parses everything out. Once, I put that in there if I just want to run the thing once. Then you have loop, init values, init network, init display, while one, and sleep for 2 seconds and wake up like every hour or whatever and just go out and check again for new data. Pretty straightforward. And if the name is main, loop. That should all work. So let's give it a shot, shall we?
So you want to push that to the winner?
Yes, exactly. And this is, which let's make sure we got the file name right. This is main.py. And that is located inside the presentation directory. I could have done that. All right, so we're going to go back to our good old web REPL. Web REPL. We're going to send a file. We're going to choose a file. All right. Presentation, main.py. We're going to ignore the next 6 times I open that. And we are now going to choose a file again, main.py, and we're going to send it to the device. Sending main.py, 2226 bytes. All right, boys and girls, ready for the moment of truth?
You know it's done.
Yeah,
Okay.
it's pretty quick. You want to be technical about it? That's probably a good question. All right, so let me hit the reset button. All right. One, two, three. All right. So in a perfect world, this would have worked. But the core of it is not like that connection.
Go back to your terminal there. What is it showing me?
That's a great question. I don't have web REPL right now. I do have Pico still fired up though. So if we go back over here,
Import error.
import module.
Date time.
What?
Date. Maybe time just does the whole thing.
Let's take a look. Let's definitely something to take a look at. The great thing about it is we have control.
Did you try this at home?
Yes, I've had this running on my system for quite some time. I was making some modifications to it, which I shouldn't have done. No, it was running quite well on my system. But thank you. Next month when you're presenting, I'll remember this. All right, can I connect back to it through this, or is it going to give me grief? I will reload it. And I will type in the wonderful thing again.
Do you think it executed it and got the IP?
No, it didn't. So it's going to give me grief. Oh, no.
Okay, all right. At least it executed that portion.
Yes. All right, so
resend.
Let's choose a file. Let's choose main pi one more time. Let's send it to the device.
And
all right. It's uppercase. So the hello world is different. There we go. Actually, let me be more make it more challenging. And hello world, Omaha,
Nice.
And it will go through the process of flipping through. That's just a battery. It's not a heavily contemplated thing. But the good news is I have this example out. It runs through three screens: location, the time the sample was taken, the particulate level in numbers, numeric values, and the monitor, which all pulls from an API, which gives you an idea.
I see.
Yeah. So
I'm assuming that the flip side is also true, where somebody is using one of those and sending data to.
Yes. Yeah, it works both ways. So that gives you an idea of what it can do, but that's a complete system in itself. And I don't even know how long it'll run that battery. It'll probably run for quite a while on that battery. So that gives you just a quick idea what some of the capabilities are. Let's see where we're at slide one. I'm so glad the demo went well. I'm due, man. I'm due. That's all I can say. So, but it's really simple. I mean, that's a really simple idea what it does. It just goes out, grabs data off the web, pulls it back to you, shows it to you. That's all I wanted for that. Couldn't you have written an Alexa skill for it and have it tell you to you verbally? My response to that, once again, is bite me, but I wanted to play with this component. But that gives you an idea how it's laid out. The script, we looked at a little bit. It's just a really simple loop. Get the data, display screen 1, sleep 2 seconds, screen 2, screen 3, It's been an hour, get the data again. About as simple as you can get this for a project. I do need to update the initialization section like I was talking about earlier, just put the JSON in it. There's some stuff, there's some very cool programs available that are written in the Lua environment that you can actually push to this, which will let you dynamically set the PSK, SSID, all that information dynamically so you can have it actually have something, and then other people can update it dynamically and stuff like that. I could do that with this. I can write a web server, I can do all sorts of stuff into this, I can make anything available through it. So if I want to make it easier for somebody at a remote site to be able to push something to it, I'd have it pop up like that MicroPython 7, then you just overwrite it. Really simple. Yeah, so reboot the device and it works. So I'm very, very happy, very little surprise. Some optimizations. How would you optimize? First off, you wouldn't have Wi-Fi on all the time. I don't need it on. Only time I need it on is every 2 seconds, every hour. Having it on the rest of the time is a pain in the butt. The only reason I have it on is because of the web REPL, because I want that to be available to me. So that reduces the power by quite a bit. Yeah, putting a web server on, enabling the app so you can set the parameters and restart the device would be nice. Yeah. So, and nice. The next gen AQI, if I write another one, I would consider using the TT Go T5 ESP32 1.54 inch ePaper display with a speaker. We got to take a look at this, boys and girls, because this is very cool. TT Go, what was it, T5? So if I wanted to go the next generation, go full out, all the way, TT Go This has ESP32 in it, so it's much more powerful. It has e-ink display, so it doesn't use power except when it redraws the screen. So very, very nice. And it's 29 bucks. For less than 30 bucks, you can take the leap to the next generation, have it all be e-ink and stuff like that, which would be very, very cool. Yes, there's a speaker that's where's that? I thought it was on the power line, but I guess it's not. I don't know where the power line is in with this one. This one may not have came with a speaker. A lot of them do, though. Yeah, this one doesn't have a speaker. A lot of them do, which is kind of cool because you can actually add additional capabilities to it. That one didn't.
How good is the sound quality? Can you play music?
No.
No.
No, I mean, you can make a beep noise. You can make a 2 beep noise. I mean, it's pretty limited in its capabilities. I don't think anybody's written any sound libraries for it, but it could probably play a very simple tune just by setting pitches and stuff like that. I believe all it can do. Yeah. But audio alerts would be kind of cool. Cost at Amazon is about 35 bucks. It's also available at AliExpress, eBay, so on. There's a whole bunch of stuff. There's examples, a whole store set up. These is part of their deal. Come on. How to get started with the ESP8266. Squix Thing Plus Pulse has a really nice kit called the ESP8266 Weather Station. It sells for about 25 bucks on Amazon. That's like a 1.5 inch multicolor OLED display, a little ESP8266, and instruction manual how to do a little breadboard, all you need for it. It also comes with temperature humidity sensor, which is kind of nice. But he has a really nice guide written on how it works. He's also come up with some other stuff. He's got a really cool touchscreen version with the OLED in it, which is kind of cool because that brings up a whole another set of possibilities what you could do with it. Yeah, you can also search for the ESP8266 weather stations on AliExpress and others to find similar kits for $12. They kind of work similar to the way that this does. They go out, they hit weather underground, they pull down the information, they display it. Is how they work. There's also the capability of talking to finding out what planes and stuff are overhead. There's the whole network of ESP8266. Yeah, that flyover stuff. That actually he has another example for that, and it was pretty good. Most of the people who have the 8266 weather station also have instructions for how to lay it out, but that gets you back to doing breadboarding and stuff, which is cool, and I enjoyed quite a bit, but for my project, that's all I needed. Getting an ESP8266 like the one I have, you can find it for 10 bucks if you look around a bit more. If you don't need an OLED, you can get it for really cheap, a couple bucks, and get you started playing around with it. I've enjoyed it a heck of a lot more than I thought it would. If you want to consider working with AC outlets, consider the Electro Dragon site. They have ESP8266 with a couple of 220-volt relays for as cheap as 10 bucks. So you can start really playing with it, having the fun. I encourage caution with this as well. But there's things like MQTT, which is let you place, if I want to start pushing data to remote sites about like humidity, stuff like that, I can use MQTT for that. There's IFTT, if this, then that, for doing automation. There's all sorts of capabilities of that. Whole sorts of stuff. You can have Alexa, I believe, talk to if this, then that, so you could actually have this do something in terms of switches and stuff like that. The possibilities are pretty much endless on there. But yeah, very cool stuff. Other projects, ESP8266 can use sensors that work with Arduino, so there are a lot of projects, moisture, light, temperature sensors, and so on. But somewhere along the lines, you run into somebody who tries to create what is called a solar theremin, which is you put a little solar panel on it, you put a light on it, and how much you cover it determines how much a horrible noise it makes. So, yeah, exactly. So it's pretty cool stuff. The 8266 weather station is really cool. That was probably talked about that. Yeah. But you've got requests, JSON supports, you can do a lot of things. You can post information, you can do all sorts of stuff with it. Future of the 8266, still going strong. It's been around for a couple of years now. New tools are being developed. The Arduino IDE is continuing to improve. I don't use the Arduino IDE because I'm a Python kind of guy. I gotta say, sometimes I think the Arduino IDE would be kind of nice because it has a whole bunch of built-in projects available. Like one of the ones they have is a Wi-Fi scanner, which will go out and figure out access points, all kind of stuff, names, all that kind of stuff. Has all sorts of stuff built into it. You can just flash it to it, no problem. So it's pretty straightforward. One of the great things about these are, if you do burn it up, blow it up, you don't really care that much because you just buy another one like I did. ExpressF has created a successor to the ESP8266, which is called the ESP32. The ESP32 is a single and dual core versions are available.
Do they usually have different cases available for those?
Most people 3D print them.
Okay.
But there are available all sorts of stuff out there for them.
I suppose that would make sense considering how many different little small form factors there are.
My next stop was going to be first.
But that's, but no, they're pretty cool little chips to play with. I mean, I would like a better case for that one, obviously. I was thinking actually about, given the capabilities, I was thinking about just putting some Suguru stuff on there. Suguru, yes. And just kind of molding a case of that because it can handle a pretty high range of temperature. So I think it would probably be able to handle it pretty well, being totally enclosed. So that's all I got. Links to the slide, I'll throw them to John. If anybody is interested, just go ahead and ask me. Alex Restman, good. Talk Python to me. If anybody's into Python, Talk Python to me is a great website to do podcasts. They've had 2 podcasts about MicroPython. One they did really early on, and one they did a couple years ago about the Adafruit system, which is pretty cool stuff. And there's the GitHub for my air quality indicator project, which apparently has a bug in it, which I got to fix now before I take it off GitHub. I know. That's what you get what you pay for. That's all I got. Thank you, everybody.
Yay. Good stuff. So we voted not to have a July.
Do you have a quorum?
He is the quorum.
So we'll meet back in August for Brian.
Woohoo!
Are you in edit mode? No.
No.
Oh, yeah, it says A.
Oh, I guess I'm logged to the slide, so yes, I am.
You can put it in cancel.
Straight through. There we go.
Yep.
Yes. Very cool. Man.
I am out of town in August. Wonder why that is.
Yeah. But Q4OS is actually not too bad either. I gotta say, I'm not 100% thrilled with it. Let's put it that way. But it's an idea. All right.
Sweet. Well, I'm going to end the broadcast.
Yes.
Thanks, everybody.